Good morning, my name is Adam. Welcome to the Tapir tutorial series. In this episode, we will talk even more about error handling. Very often there's more than one thing that might go wrong, and for each case we want to provide a different response. So in the previous episode we've seen how to differentiate outputs for success and error cases. So very often the response that you want to send in case of success is completely different from the response that you want to send in case of an error. But you may want to differentiate this even further and provide various responses in case of success and various responses in case of errors. So we'll see today how to do that. So just to recap, we've seen that if you have an endpoint description, you can define the successful output. Let's say we'll use a JSON body for a result. I don't have all the imports here, so this will be read, but that's just an illustrative example. And you can say that you have an error output with a string body, right? So Tapir out of the box supports supports output variants, where the first variant corresponds to success and the second variant corresponds to an error. So we have two completely different responses here. Also note that this directly translates to the high-level representation that we need to provide, right? So if we provide the server logic here, what we need to do here is we need to provide a method with a signature that it will capture all the inputs, but in the response it needs to return either a string or a result, right, corresponding to success. So we've got these two outputs, these two shapes that the output might take, and these correspond to the high-level type that we need to return from our server logic, right? So if the server logic returns a left instance, there's somewhere in Tapir there's a check that if the response is of the left class, so if it's an instance of left, then use the error output. If it's an instance of the right class, then it's the success output, right? Okay, so what's important is that in Tapir we already have response variants which are built in at the top level, which is the success and the error, and they correspond to the high-level types, which also need two variants, right? Here it's the left and the right. And what we can do is we can further differentiate at lower levels. So we can go one level below and differentiate and introduce variants of the successful outputs and variants of the error outputs. And in the same way, we will need the high-level types also to have variants. So let's see how we can do that. So what we will use is we will use one-off outputs. So a one-off output is parameterized with a list of outputs which will be chosen depending on the result of the server logic. So each such one-off output contains a list of other outputs, but it must also correspond to a high-level type with variants. So quite often this will be a Scala enum. It's a convenient possibility, it's not a requirement, so you might use other types as well, but very often it's going to be an enum which will represent the family of outputs that are possible, and this will be mapped to one of the variants defined in the one-off outputs. Okay, so as an example, what we will do is we will define an avatar endpoint. So the endpoint, it will be a get endpoint, and we will be able to ask for an avatar of a user, and there's a number of things that might go right and a number of things that might go wrong. So actually let's start from enumerating all those success and error cases in our high-level types. So we'll have an enum called avatar error. So these are the things that might go wrong, right? So the user might be unauthorized to obtain the avatar of a given user. You know, maybe the avatar is private or something like that. Unauthorized, yeah. Or the avatar might be not found if we provide an invalid user ID, or there might be another error which we will just share through a message. There's also a number of things that might go correctly. So the avatar avatar success. First of all, we might find the avatar, so we'll just return the bytes of the avatar image, let's say, like an in-memory design, and we might also have a redirect. That's an enum, not a case. We might also have a redirect scenario where the user provided a link to an external avatar, so we will just provide a location as a string here. Okay, so these are the high-level types for which we want to define our outputs. So we want to define an error output with 3 variants and a success output with 2 variants. So let's actually start by defining a single variant. So we will start with the redirect variant because it is actually the most complicated one. Before we do that, let's take a look at how we can define and how we can capture outputs as values. So in the case of the redirect variant, what we want to have the redirect. If the server logic returns a redirect instance, what we want to do is we want to return an HTTP redirect. So this consists of a status code plus the location header, right? So we need to actually map. We actually need to map this instance into 2 outputs. So we've already seen more or less how we can combine outputs, but let's expand on this a bit. So first of all, we've got the status code output, which we will use, and the status code output is parameterized with the status code to return. So it's a fixed output, meaning that it doesn't depend on the output of the server logic. It just always returns the temporary redirect, so the 307 status code. And what we can do is we can actually, so that's a value, so we can store it in a value. So let's say it's output 1, and that's of type endpoint output of unit. Okay, so the status code is an endpoint output that maps a unit to the status code. A unit here means that it actually doesn't need any values to produce the output, right? We've seen other outputs also. So we've seen other output, for example, a string body, right? A string body is an output, so it can be typed as an endpoint output, but it maps a string to the output, which is the actual value that should be mapped, right? So it's not a constant, it's not a fixed value output, but it depends on the output produced by the server logic. That's a bit different from the status code output. So we've seen a couple of these outputs, but what we are doing right now is we are capturing these as values, we are assigning them names so that we can work with them in a more clear way. So we also might have another output which will map a string to this time. This will be the header output, and the header will be location. So that's a description of an output which maps a string, as specified here, maps a string value to the location header name. So what we need to do now is we want to combine these 2 outputs. So as we have seen in the previous episode, what we can do is we want to actually produce multiple outputs. We just need to call the out method twice. So we could do that here. So we could define an endpoint which has 2 outputs, a fixed status code output and the location header output, right? So by combining these 2 values, we actually only need to provide a string, right? Because if we combine a unit output with a string output, we still get a string output, because we still only need a string to actually produce the output. So that's one way of defining this. Another one is to actually combine an output into a composite one. So we can say, we can remove this and we can say .end02. Okay, so we can provide both of these outputs at the same time. And in fact, what Tapir does internally is when you call .out, it simply calls .end on the output defined so far. So that's exactly what happens under the covers. So what we can do here is we can say that O3 will be an endpoint output, also typed as a string, and it's a combination of these two outputs. So we've got this composite output which consists, we've got a description of a composite output which consists of these two outputs which we can use. Okay, and finally we can, because we wanted to cover the redirect case, we can map it. We can call the map2 function, which we have seen in the last episode. So we can map it to the avatar success.redirect. And now we need to adjust the type over here. So what we are saying here is we are taking the fixed status code output, we are taking the header output, we are combining it into a composite output. So now it's a description of a composite output consisting of these two base ones, and we are mapping it to the redirect class, meaning that when the response will be constructed, the redirect instance will be given to Tapir. So what Tapir will do is it will first map this redirect instance to a string with a function constructed using this map2, right? So this map2, if you remember, it's a macro which generates code which maps the redirect instances to the tuples that correspond to the output. Here the tuple it's like one tuple, a string, so it will map the redirect instance to the string, and then what will happen is it will say okay, so I've got a composite output, so let's split this string into the values needed by both of these outputs. So the first one doesn't really need a value, right? So it will just obtain a unit, and then the unit will map to the status code, and this one will actually need the string, so it will get the string from the redirect and produce the appropriate header. Okay, that's a bit of the internals, but it might, make it a bit easier to understand what's going on. Okay, so we've got these outputs. So what we can do now is we can describe the one-off output, which will have multiple variants. So we will describe the success output, and it will also be typed as an endpoint output because that's what we need. The output should correspond to the avatar success class. Okay, and what we will do here is we will use the one-off output. So the one-off output is parameterized with a number of variants which create this one-off output. So such a variant consists of two parts. So the first part is the output that should be used for the variant, and the second part is a function determining if the output should actually be used for a given value, right? So the output, the server logic will return an avatar success, and now we need a way of determining which variant from the list provided here should be actually used. So each variant is accompanied with a function which takes the avatar success instance, returns a boolean saying yes, this variant should be used, or no, it shouldn't be used. So we can use the one-off variant constructor here, a method which creates a variant, and we can simply pass in what we have created over here. Okay, so such a variant. So as I said, it needs the output, but where is the function? So the function, when we are using the one-off variant method, is created automatically at compile time, and it will check the runtime class of the instance being passed to verify if it matches the class that is used over here. So not all types correspond to classes. Like if you have a generic type, for example, like a type parameterized with other types, right, like a list of a string, you cannot verify at runtime if the given list instance is indeed a list of string because of erasure. So if we tried to provide an output corresponding to a list of string, this would be a compile time error. Here, however, we are using simple case. We are using simple enum cases. This enum case corresponds to a top-level Java class, so the runtime check will run just fine, and this compiles just fine as well. So this one of variant will takes the output to use, and it creates a function which will use this variant if the runtime type of the avatar success instance that is produced by the server logic will actually be avatar success.redirect. In a very similar way, we can use a variant. We can define the other variant, so the found. So for that we take the byte array body output. So this output has the type endpoint output of array of byte. So we of course need to map it to avatar success.found. Okay, awesome. So we've got the success output described. So now what we might do, let's hide this for a second so that we can see the avatar error definition. We also need to describe the error output, right? And it needs to be an endpoint output of avatar error. It will also be a one-off. Okay, so the first case, the other case is simple. One of variant, it will be a string body mapped to avatar error.other. Okay, however, there is a problem with these two cases. So these two cases, they are parameterless enum cases, meaning that there are no top level, they are not compiled into Java classes. They are just values. So we cannot just do something like this, for example, right? For two cases. First of all, like this, it's not parameterized, so we would need to, use some kind of an empty body, which we'll do in a second. But second of all, we cannot use the one of variant method here. This would also be a compile time error, because the unauthorized does not have a runtime class for which we can check at runtime if the instances match. So this won't work. So what we can do instead is there's a dedicated variant constructor method called one of variant singleton matcher. What it does is it takes first the output, the output to use. So this will be the fixed status code output. Once again, we will use the status code unauthorized, and second parameter is it takes the singleton type, the singleton value that should be used when matching this case. So we are simply using this unauthorized value over here. Okay, and this should work just fine. In a very similar way, we are handling the not found case. So we create a one of variant which will be used if the value passed is equal to this singleton value, right? So it's a simple check, right? So if the result of our server logic is an avatar error.notFound, like if it equals, then we will use this output, and of course we need to use the not found status code over here as well. Okay, awesome. So we've got this one of outputs described, both success and error output. One important note is that unfortunately it's not possible to verify at compile time that we've actually covered all the possible branches, right? So here we've got two branches of the enum, of the high-level type, and we have two variants, which is correct. But if we forgot one branch, this would also compile, and we would get a runtime error if we encounter a result which like a variant which is not covered here by the one of description. So that's something, unfortunately, that we have to live in, because these values can be composed arbitrarily and they can be assigned to values and so on. So it's not possible to verify the exhaustiveness of the one-off output description. Okay, but with that caveat out of the way, let's actually describe the endpoint which we will use to test our solution. So what we do is we create a get endpoint, and it will be the user/avatar path, and we will accept a query parameter called the user ID, and as a success we say that we want to return the success output. In case of error we want to use the error output. Okay, awesome. And now we need to provide the server logic. The server logic should it takes an int, if you remember, and it returns either the error output, so the avatar error, or the avatar success. Okay, why is this red? This should work fine. Maybe it will in a second. Okay. So now for the server logic, just something simple. In case of one, we return avatar success.found, and we will just convert this to bytes. In case of two, we return a redirect to https example.org/me. In case of three, we return a left avatar error unauthorized. In case of four, we return another error. We don't like this user, sorry. And in any other case, we return an error, so avatar error not found. Okay, so you can see here that we've got these two levels of variance, right? The first level is the right left. So this variant this high level value specifies if we should use the error output or the success output. And then we've got the second level below this, right? We've got the variance for the success, and we've got variance for the errors. Okay, and that's it. I've got the standard Swagger definition over here and the Netty definition, the Netty server over here. I'm not sure why this is red, but let's actually try compiling this. Scala CLI variance and Scala. Okay, value error output. Oh, error out with put. Okay, now it works. Success. Okay, anything else? No, I guess we're good. Okay, cool. Let's try running this. Okay, it started. So let's try running a couple of requests. So starting with one, we've got the smiley face. With two, we've got the temporary redirect to our location. So everything designed. With number three, we've got unauthorized, as you can see over here. With number four, we've got a bad request, which is the other case. If you recall, this mapping over here, right? This other case, we didn't specify status code, and for error outputs in general, if an error variant, an error output in general doesn't come up with any status code on its own, the status code for 100 will be used by default. And for five, we've got not found. So this works great. Okay, so let's see if what we have described here is correctly described in the documentation, in the generated Swagger docs as well. So these are the docs for our application, and as you can see, we've got a couple of status codes documented over here, right? So we've got the successful status codes, which are the 200 status code and the 307, which is temporary redirect with the location header. We also have the invalid cases, which might happen. So the ID might be malformed if it's not an integer. We might have unauthorized and not found. We didn't provide any description for these, which is also possible, of course, using Tapir, but we didn't do that. So they are just like, you know, empty status code, nothing more. The important thing is that the documentation reflects precisely what we have defined in the code. Okay, so that's it. Let's do a very short recap what we have seen. So what we are trying to do is we've described an endpoint which, apart from having success and error output variants, further specializes this and introduces a second layer, a lower level of variants, where we can have both success variants and error variants. So these must correspond to some high-level type. So here we have used enums to describe these high-level types. Then we have seen how endpoint outputs are typed. So each description of an endpoint output is an instance of the endpoint output class, which is parameterized by the values which are mapped to the response. So a fixed status code output doesn't map any values. A header output maps a string values, which is the value of the header. Then we have seen that we can combine headers into composite endpoint output descriptions, and such a composition combines the values that are needed to actually create the outputs. Then we have created the variants. So each variant consists of an output and the function which determines if the variant should be used. So here the function is automatically created, and it performs a runtime check on the class, on the instance that is being passed from the server logic, if the runtime class matches the class provided over here. For error outputs, we also have seen that if we have enum values, this is over here, if we have enum values which are not translated into classes, we can use the singleton matcher, which will generate this matching function, which will check if the value returned from the server logic is equal to the value provided over here. And finally, we have described our endpoint. So we have factored out these two outputs as values, which makes the endpoint description a bit more concise. Another thing is that you can reuse these error outputs in main output definitions. So that's also something that we'll cover later on, but that's also kind of a teaser how you can, reuse parts of an endpoint description in many places. The function over here, the server logic function that we need to provide, the shape corresponds to what we have described using high-level types over here. And that's it. Thank you very much, and see you next time.